This is, excuse me, 5.2 direct variation, and we're going to start with some vocabulary. Okay, so the first one is a direct variation is a relationship can be represented by a function in the form y equals kx, where k is not equal to 0. One thing I want you to notice is that nothing is being added or subtracted from kx, so it's just y equals kx. The constant of variation for direct variation, k, is the coefficient of x. So k is the constant of variation for direct variation. All right, by dividing each side of, oh, let me go back to this, I think right here. Oh, never mind. Okay, by dividing each side of y equals kx by x, you can see that the ratio of the variables is a constant. So k is equal to y over kx. Y over x. K is equal to y over x. To determine whether an equation represents a direct variation, we're going to solve it for y. If you can write the equation in the form y equals kx, where k is not equal to 0, it represents a direct variation. So something important to note about the y equals kx is that the line goes through the origin. So basically this is just a equation of a line. It's very a basic equation, and it goes through the origin. All right, so let's look at some problems we're going to be doing on the homework examples. First of all, it says a recipe for 9 banana nut muffins calls for 1 cup of flour. The number of muffins can be made varies directly. So I want you to notice it says varies directly. So whatever comes before varies directly, the number of muffins, and then varies directly with the amount of flour used, that can be made into a ratio. So number of muffins is first, and we put it over whatever comes after the varies directly, so the amount of flour. All right, so there are 2/3 cups of flour available. How many muffins can be made? Okay, so we're going to put the number of muffins, which starts off with 9, over 1 cup of flour. So we put the number of muffins over the amount of flour equals number of muffins is what we're trying to find. That can be made out of 2 1/3 cups of flour. So this is basically our proportion. We've already solved these before. Cross multiply, I would definitely use my calculator on that. So x equals 9 times 2 1/3, which would be 21 muffins. So 21 goes right there. All right. Number 2, determine whether the equation represents a direct variation. If it does, find the constant of variation. All right, so we're going to take this equation and we're going to solve it for y. So we're going to divide each term by 2, trying to get y by itself, and we get 5/2 x minus 1/2. Since there is a term being added or subtracted from the x term, then it does not represent a direct variation. So we're going to circle B. Now, if we had 2y, this is just an example, equals 5x, solve it for y. Y equals 5 over 2x, then this represents a direct variation. And the constant of variation would be 5/2. So this is a different problem, but I wanted you to see it because it's the only example I could think of for this particular problem. So this one is not a direct variation, does not represent a direct variation because there's a term being added or subtracted to the x term. All right, number 3. Suppose that y varies directly with x. So that means y over x. Write a direct variation equation that relates x and y. Then find the value of y when x equals 14. Okay, so we have y equals 8 and x equals 7. So start with y over x equals 8 over 7. And then we're going to solve it for y. So cross multiply. 7y equals 8x. Divide by 7. And y equals 8 over 7x. So this is the first, goes in the first blank. They already have the y equals, so all you have to do is type 8 over 7x. Now, what is the value of y when x equals 14? So now we're going to put 14 in for x. And again, you can use your calculator if you want to, or if you know how to cross reduce, you can do that. So 2 times 8 is 16. So 16 goes in the next blank. Okay. All right, number 4, graph the equation, graph the direct variation equation. So in this, you're going to click on, well, first let's do a t-chart. All right, so we're going to start with 0, and because remember this has to go through the origin. So y equals 10 times 0, and y equals 0. Okay, now let's pick a number like 1. We're just going to pick a number close to 0, and we're going to put in y equals 10 times 1. So that's 10. Okay, so on here, and I'm going to show you this one, then I'll show you another one that's similar to it in live action. Okay, so we're going to first click on the line tool. Okay, so the line tool is down at the bottom, and it looks like a straight line like that. So click on that, and then click on the graph, and you're going to put a point, so you have to click on it, at 0, 0. Then you're going to make your next dot be 1, 10. So go to the right one and up 10. Okay, and it draws a line. So let's see if this will work. I think I have the wrong thing up, so let me try this one. All right, and we are looking at problem number 4. This is a different problem, but it'll help you to see. Okay, so this one will be y equals 2x. So first we're going to click on the graph, click on the line tool right here, and 0, 0 is going to be the first point. So we're going to click on 0, 0. I may need to do this on with my mouse. All right, so we're going to click on 0, 0. Now see how that line shows up? All right, now if you put 1 in for x, 1 times 2 would be 2. So we're going to go up like that. So that is the correct answer. So I just wanted you to see how that actually worked. Okay. All right, so that's how you graph on the Math Excel program. All right, number 5 says when distance d, u bike, varies directly with the amount of time t, u bike. Okay, so that means that d is over t. Okay, remember if it says varies directly, whatever comes before varies directly is on top, whatever comes after is on bottom. Suppose you bike 11.8 miles, so that would be distance, over in 1.25 hours. That's time. All right, so what is an equation that relates d and t? So first of all, we're going to cross multiply, and we're going to solve for d. Always solve for whatever comes first when it says relates d and t. So we get 1.25 d equals 11.8 t. I'll move this over a little bit here. And then we're going to divide by 1.25. So we want to get d by itself. We want to solve for d. So use your handy dandy calculator and you get 9.44 t. So they have multiple choice here, 9.44 t. Okay. All right. Now I need to look at these graphs. Now, to be honest, these are not my favorite graphs because of the smallness, but I'm going to show you what they're doing here. All right. Notice this goes from 0 to 30. And if you count these little dashes up to 0 to 30, you should get 15. So whenever you divide 30 by 15, that's going to tell you what they're counting by. So they're counting by twos. 2, 4, 6, 8, and so on. Now look at the bottom. So it goes from 0 to 5. So we're going to take 5 and divide by how many dashes there are here, which would be, if you count, is 10. So 5 divided by 10 is 0.5. That means they're counting by 0.5. So this is 0.5, this is 1, 1.5, 2, and so on. So we're looking for first, let's do a T-chart. So 0, put 0 in for, oh, this isn't X and Y this time, is it? It's actually T and D. Let me see if I can draw that better. All right, put 0 in for T and solve for D, and we get 0. Now put 1 in for T and solve for D, and D equals 9.44. All right, so we need to look for where it, the T on the bottom is 1. So here's 1, and we want to be able to go up to where, let's see, right here, there's 1. So that's going to be 2, 4, 6, 8, 10, 12. Okay, so that's 12 right there. So it's not this one. We want a little bit more than 8. All right, so let's look at the next one. So this is 1, and right here, that is 2, 4, 6, 8, 10, 12, 14. So it's not that one. Okay, go to the next one. I want 1, so here's 1. Right there, 2, 4, 6, 8, 10. Okay, so it's almost to 10. So we want 9.44. All right, so look at this one. This is 1, and that's not even up a full 1. So it's going to be C. Okay, so you're looking at the one that's the closest, because these are not going to be exact when they're decimals. All right, that took a little bit. Sorry about that. All right, number 6. For the data in the table, tell whether y varies directly with x. If it does, write an equation for the direct variation. So what we're going to do is y is over x, and we're going to first do, this is x1, y1. So we're going to do 25 over negative 10. Cross multiply, we get negative 10y equals 25x. Divide by negative 10. And y equals negative 2.5x. So that's with the y, x1 and y1. Whoops. Okay. Move all this over. We got to do this 3 times. All right. Now we're going to do the next one. So do y2, x2. All right. So we get negative 2.5 over 1. Cross multiply. Well, that one's pretty easy. Negative 2.5x. All right, then we're going to do the last one. So this is y3 and x3. All right, so we're going to do negative 10 over 4. 4y equals negative 10x. Divide by 4, and we get negative 2.5x. So since all of them ended up being the same direct variation, then this is a direct variation. So we're going to mark A and write negative 2.5x. All right, getting close to being done. All right, we're going to do the same thing with this one. So this is x1, y1. So y over x equals, again, it says y varies directly with x. That's why I do y over x. 6 over 2, cross multiply, divide by 2, and y equals 3x. Do the same thing for the next one. This is x1, I'm sorry, x2, y2. So equals 8 over 3. 3y equals 8x. Divide by 3. And y equals 8/3 x. Now, I'm going to give you a hint. If you don't get the same equation on the first 2 times you do it, then this is not a direct variation. So no, y does not vary directly with x. So you don't have to do it all 3 times. If the first 2 are different, just stop and say no. All right, number 8. Suppose y varies directly with x. So y over x And we're going to write an equation first. Y is 5.4. X is 0.9. Cross multiply. And divide. Oops, 0.9. And we get y equals 6x. So this is 6x here. And now we're going to graph. And again, on these, they should all go through the origin, because when you put 0 in for x, y equals 0. Now I'm going to put 1 in for x, and y equals 6. So these really T-charts should be really easy, probably even be able to do them in your head. All right, so click on the line tool, and then the origin is our first point. And then our next point would be right 1 up 6. And then whenever you do it on the computer, the line will be formed. Okay. All right, number 9. Tell whether the two quantities vary directly. Okay, so if they vary directly, the question you're going to ask yourself is, as blank increases, so whatever's first, does whatever's second. My S's are pathetic. Increased. Okay, so first thing we're going to write, as the number of correct answers, you can say this in your head too, I'm just writing it. As the number of correct answers increases on a test, okay, does the score on the test increase? Okay, and that would be yes. As you get right answers, your score on your test will get bigger. So you're going to find the one that says yes, so not going to be B or D, and you're going to find one that says when it increases, when one quantity increases, the other quantity also increases. So that's C. Okay, so not A. Okay, so do the same thing for number 10. As the score on a test increases, does the number of incorrect answers on the test increase? Okay, well that would be no. Okay, when one quantity increases, then the other quantity does not increase. So when the score on the test increases, then the other quantity, the number of incorrect answers, does not increase. In fact, it should be decreasing. So that will be A. Okay, all right, so there's those examples. Now you're ready to do the homework.